Okay, hello Year 10. If you're watching this, well done for being proactive and have a look at the video to help you. We're just going to do a bit of a recap on probability to start with, and then we'll look at a few things. So we're going to look at tree diagrams, something called AND probability, and something called OR probability. We'll look at some more terms along the way as well. But just to start off, let's think about probability. Probability can be represented as a percentage. So for example, something could have a 20% chance of happening, or we could write that as 0.2, that's also fine. Or we could write that probability as 2 out of 10, in this case, or 1/5. Okay, so of these, the one that we like the most is the fraction. Okay, we like the fraction because it tells us the most information about the probability. Okay, so this is 2 out of 10. So if there were 10 things, 2 of them were likely to happen. Okay, so write as a fraction when you can. Okay, so keep that in mind. Next thing to think about is what fractions are actually out of, or sorry, what probabilities are out of. So probability goes between 0 and 1. Okay, it can't be more than 1 and it can't be less than 0. Okay, just a few definitions. 0 probability means impossible. There is no chance of it happening. And 1, we call this certain. So that will definitely happen. Okay, another one you might think about is 0.5, exactly halfway between, or 50% we can call evens. Okay, so you've got an even chance or even probability of something happening. Okay, so a really quick example, if I have a coin like this, it's got heads on one side and tails on the other. If I flip it, the probability of heads is 0.5. Okay, it's got a 50-50 or an even chance of being heads or tails. You may notice I'm also writing P brackets. This means the probability of. Okay, so probability of heads 0.5, probability of tails is also 0.5. Okay. Okay, so thinking about coins, we have 2 here. If I flip 2 coins and I record the results, then I'll show you how I can represent this using, well, in 2 ways. I'll show you how I can represent it using a sample space, and I'll show you how I can represent it using a tree diagram. So we're going to flip 2 coins and then record the results. So the first way of recording these results is by a sample space. So if I draw a kind of grid like this, and for the first coin it could be heads or tails. For the second coin it could also be heads or tails. So this gives us all the kind of possible outcomes from this experiment. So we could have 2 heads, which we'll write as HH. We could have one head then one tail, so HT. We could have tails then heads, so a tail and heads, or we could have 2 tails. Okay, so from this grid we can see I've got 4 results, all different, and I could answer some questions. So for example, I could say, well, what's the probability of flipping 2 heads? That would be 1 out of a possible 4, so that would be a quarter. I could also ask, what's the probability of 2 tails? Well, again, that's 1 out of 4, so a quarter. I could say something like, what's the probability of getting at least 1 head? So I could say, I could literally write it, at least 1 H. And we'll have a look at this and we'll say, right, well, that's at least 1, so that's 2. This one and this one, so that's 3 out of a possible 4, so that's 3 quarters. Okay, I could say, as a final question, I could say probability of rolling one of each, so a head or a tail and a head or a tail, and that would be this one and this one. So that would be 2 out of 4, which simplifies, of course, to a half. Okay, so that's a sample space. Sample space. And that is one really good way of showing the probabilities for an experiment. Okay, what I'm going to do now is I'll show you how it works with a probability tree. So if I just delete this. Okay. Okay, so for a probability tree, I start on one side, and what I do is I think about having my 2 flips. So flip 1 and then flip 2. And so for each one, I have 2 routes it could take. So I could either go heads or I could go tails. And what I'm going to do is I'm going to write the probability of that on the branch, if you will. So heads a half, tails also a half. Okay, so that's the first flip. And then what I do is, because I've got heads in this one, I draw 2 more branches from that one. I draw 2 more branches from the tails. So again, I write heads, tails, heads, and tails. So I have a half, a half, a half, and a half. Notice that none of the probabilities have changed at all. That's because if you flip one coin, you get tails, it doesn't change the probability of what happens next. You've still got a half chance of heads or tails. Okay, so how to use a probability tree? Well, here's what I do, and here's probably quite a good method for you. If you go along the branch, what you can do is you can write what the outcome is. So this outcome would be heads, heads, so I'm going to write P, H, H. This one goes heads, then tails, so I'm going to write P, H, T. This one goes tails, then heads. And this one goes tails, tails, so P, T, T. Okay, now to work out what these probabilities are, I know that we already know what they are, but just to show you it using a probability tree, these are what's known as AND probabilities. Okay, so this is the probability of getting heads and then heads. So this is heads and heads. Heads and heads. So because it's heads and heads, I multiply the 2 probabilities together. So if I go along this branch, I do a half times a half, and that gives me 1/4. So probability of heads, heads is a quarter, and that sort of marries up what we just looked at with that sample space. Next one, let's do it again. So we go heads and tails, a half times a half. In this case, they're all going to give me the same result. Tails and heads, half times a half. And finally, tails and tails, so a half times a half here. So that gives me a quarter. Okay, so each result is equally likely. We times along, and that's given us the probability. Now, one thing to pay really close attention to is these 4 probabilities are the only probabilities there are. So they must all add up to 1. So a quarter plus a quarter plus a quarter plus a quarter is 1. Okay, so all the probabilities must add to 1 because it has to be one of them. Okay, let's put a little note there. All probabilities add to 1. Okay, let's have a little think about OR probability. So I'm just going to delete this little bit here and that. So think about OR probability. If I was to say, what's the probability of getting heads, heads, or tails, tails, then, bless you, then you don't times them, like with and. What we need to look at is, it could be this one here, so it could be a quarter, or it could be a quarter here. So the probability of heads, heads or tails, tails is this one and this one. And what we do is we add them together. So the probability of it being heads, heads or tails, tails is a half. Okay, and we could do this sort of for other possibilities as well. I could say what's the probability of heads, tails or heads, heads or tails, tails. And in this case, it would be a quarter plus a quarter plus a quarter, which gives me 3/4. Okay, so for or probability, we add, for and probability, we times. Okay, so let's think about a different example for a tree diagram. In this case, I'm going to have a bag. Here's my bag. And I'm going to put in to this bag some counters. So I'm going to have 1, 2, 3 red. And I'm going to have, let's say 1, 2, 3, 4, 5 blue. Okay, so I've got 3 red, 5 blue, and I want to make 2 picks, so I'm going to pick 2 counters out of the bag. One at a time. Okay, so just to be clear on this, I'm going to take one out, put it back, then take another one. Okay, and this sounds a bit trivial, but this is really important what I'm saying here. I'm going to put them back after I've taken it out and recorded it. Okay, and I'll show you how that works with this tree diagram. So to start off, I'm going to draw my first 2 branches, and I'm going to write on the top one I'm going to put a red dot, and on the bottom one I'm going to put a blue dot. So the probability of getting a red, well, we can work this out. So there's 1, 2, 3, 4, 5, 6, 7, 8 in total. So the probability of picking a red is 3 out of 8, or 3 over 8. Notice how fractions make this really clear. 3/8 as a decimal is really difficult to understand, so 3 out of 8 makes sense. So if it's 3 out of 8 for a red, for a blue it must be 5 out of 8. Okay, so this is my first pick here. Draw 2 more arms off each counter, and I'll do the same again. Red here, red here, blue here, and blue here. Okay. So because I've put the ball back in to the bag, it hasn't changed the probability for the second pick. That's really important. So I've taken it out, I've recorded what it is, then I've put it back in, okay, and I've shuffled it back up. So the probability of choosing a red stays exactly the same. It's 3/8. Blue stays the same as well, that's 5/8. This is my second pick. Okay, so we can go through this. So I'm going to go probability, red, red. I'll fill these in as I go. Okay, so probability of red, red, probability of red, blue, probability of blue, red, probability of blue, blue. So probability of red, red, remember this is an and probability, so it's red and red, so we times them together. 3/8 times 3/8, well 3 times 3 is 9, 8 times 8 is 64. Next one, go along the branches, 3/8 times 5/8, that's 15 over 64. Next one, 5/8 times 3/8, that's exactly the same, that's 15 over 64. And then our final one is 5/8 times 5/8, which is 25 over 64. Okay, so you've got your probabilities here. So I could ask you any number of questions. I could say, what's the probability of 2 blues? You'd say it's 25 over 64. Okay, a red, then a blue, 15 over 64. Okay, so you can read this off straight away. A quick check, as usual. Does this all add up to 1? Well, let's have a look. So is 9 plus 15 plus 15 plus 25, does that give me 64? Well, that's 30 plus 25, which is 55 plus 9. Yes, it does. Okay, so it's all good. That equals 64 over 64, which is 1. Okay, so this is something called unconditional probability. Okay, I haven't changed the probabilities at any point during this experiment. Okay. Okay, so my last example, we'll go back to another bag situation. I'll change it slightly. Let's have some green. So we've got green, green. We've got 2 greens. And we're going to have 3 blues. Okay, so very similar to the last question in setup, but I'm going to change it slightly. So in this case, I'm going to take 1 ball, not replace it, then I'm going to take another one. This is really important because this changes what goes on. So I'll show you. So we start again with 2, that's horrible. Start again with 2 branches going off like this. So I have a green ball here. And a blue here. Okay, so to start with, the probability is 2 out of 5. For the blue, it's 3 out of 5. Okay, that's my first pick. And so I draw 2 more arms coming off. Oops, change that colour. Okay, now this is what we need to think really hard about this. If I've taken a green ball to start with, I need to think about what's left in the bag. So if I've taken that one out, there's only going to be 1 green ball left out of a total of 4 balls. Okay, so it's 1 out of 4. And that should make sense. The total's gone down by 1 and the green balls have gone down by 1. We've still got the same number of blue, so that means we've got 3 out of 4. And then we can do the same down here. So if I take a blue, then that reduces it by 1, so that becomes 2 out of 4. And that leaves 2 green, which is 2 out of 4 here. Notice how the probabilities are different on the different picks. Okay, and we'll do exactly the same thing. Go through P of green, green. Do you know what, I'm just going to go GG. So that's going to be 2/5 times 1/4, so that's 2 over 20. Don't simplify it yet, leave them over 20. I'll show you why that's useful in a second. And then go, so we've got P, green, blue. That's going to be 6 over 20. Probability of blue, green is 6 over 20. And finally, the probability of blue, blue is 6 over 20 as well. Okay, so if we add these up, 6 plus 6 plus 6 is 18, plus 2 is 20, so that works, that's 20 over 20. Okay, and by leaving it over 20, as I said earlier, that makes it easier to check this. Okay, we call this conditional probability. This is because I have put a condition, and the condition in is that I'm not replacing the ball between picks. Okay, so that's a bit of sort of looking at probability trees and how they work. A lot of the questions on the homework are going to be about that. Okay, so if you need to remind yourselves, just look back through and just be really, really careful, especially if it's conditional probability and there's an extra rule in place. Okay, have fun.